Okay, so here we have a problem where we're looking to test a hypothesis about a proportion. And we have one sample of data. We have a consumer group that believes 30% of households have exactly three cell phones. The cell phone company thinks less than 30% have three cell phones. And we have some survey data. Survey of 150 households finds that 43 of them have exactly three cell phones. So we can find proportion information. So the way this is set up, it gives us our null hypothesis here and our alternative hypothesis here. Remember, the null hypothesis always has the equal sign, and the alternative does not have an equal sign. So the null hypothesis, we're looking to see if the parameter is equal to, or is reasonable to think that it's equal to that particular value. In this case, three cell phones, 30% have exactly three cell phones. So a probability here, a proportion of 0.3 having exactly three cell phones. A cell phone company gives us the alternative. They think it's less than 30%, so the alternative here is p is less than 0.30. All right, so from the survey data, we have our our sample proportion. And so that's 43 out of 150. We do that calculation here. We get a proportion of 0.287. So it is less than 30%. So the cell phone company is going to say, right, we're right on what we were thinking. It's less than 30%. But this is just a sample of data. If the true population value is 30%, is it reasonable to get a value like this? So what's the p-value for an outcome that's this extreme? So we find just like we did in the previous example with a sample mean, we find the standard error. We calculate, in that case it was the t-score, but here we're going to calculate the z-score, and then we'll find the p-value associated with that. So the standard error in the population, standard error in a proportion, we use this square root formula, square root of the proportion times 1 minus the proportion. And so we're going to put in here 0.3 because we're assuming in our null hypothesis that's the true population value of the proportion. So we put that value in. And our sample size is 150, so n is 150. And we get a standard error of 0.037. That goes in the denominator to calculate the z-score. We take the sample proportion, subtract the population value, divide by the standard error, and we get a z-score of minus 0.35, which already at this stage, you probably kind of know where this answer is going by what the z-score is. Okay, so z-score of minus 0.35. Okay, so what we want to know is this value low enough to reject the null hypothesis? So we calculate the probability. Again, doing this calculation in Excel, we're using the normal distribution here, equals norm.dist, and then we put in the value of the sample. Then the population value we're testing, the null hypothesis, is 0.3, and we put in the standard error here, 0.037. This gives us the p-value. The p-value is 0.36. Okay, so that's a 36% chance of getting a value this low or lower. So that's the left tail probability. And obviously we cannot reject the null hypothesis. I mean, pretty much any criteria for evaluating the null hypothesis is going to be greater than that criteria. The highest it typically gets is the 5% level. And so 36% is way beyond that. So we do not reject the null hypothesis. It's perfectly consistent. This result is perfectly consistent with a true population value of 0.3. You'd need a lot more data to show that this is low enough to reject that null hypothesis.